Okay, I think we have just a minute, so we can start. Okay, I think we have just a minute, so we can start.
Ile ko se bito yena.
Dr. Umar, can you hear me?
Yeah, I can hear you, Dr. Phillips.
Please, you can start. I think you have
Okay.
enough. The rest will join. Thank you.
Hello.
Hello, everyone. Can you hear me?
Yes, I can hear you. I've made the introduction.
Hello, everyone. My name is Umar. I would like to, first of all, thank the Africans young scientists for the invitations to deliver or to walk you through data science in R areas. So in today's webinar, we are going to look at how data cleaning is being done in R and how you are going to explore your data and visualize it through the popular programming language or statistical programming language called R. Before I start, I would just like to quickly walk you through on the data cleaning itself. Basically, we are going to use the R Studio. By my left hand, it's on the top, is the R icon of the R Studio, and we are going to use the R itself, the programming language. And then the popular book of R for data science, of which most of what I am going to present is inside the book, so you can refer to it anytime. There is the link. As you all aware, R is one of the key programming languages that scientists use for statistical analysis, apart from the Python programming and other programming languages used for analysis. So basically, R is it's a computer language that is meant for scientists to do data science. In R, basically we have R itself and we have the R Studio. R is just like you having your engine of a car, and R Studio serves as your dashboard. So you cannot do without, R cannot function well without R Studio. You can actually make use of R in your terminals, in computer, or in the R console itself without having to do with Studio. But the R Studio make it more shiny in the sense that all your data set and your files can be organized into one project folder, and you can even put it down onto the GitHub repository if you want. So this is basically the overview on how the R Studio itself look like. In the top left-hand corner, you can see is the editor. It's like your text editor, like Notepad. Most of you know Notepad and Vibe. that you can use for most of your programming, especially those of you that are doing biological, computational biology, and bioinformatics of stops. So it basically serves as an editor where you can write your script and basically save your script for future use or for other to use it. And while here, it is where you can see the code is running in live stream and lifetime. And as well, you can be able to look at, you can make use of the terminals as well in the console of R. The terminals is where you can communicate with your computer using bash programming as well. So the same thing here, we do have an environment where you can see there are data and objects that are basically created from the editors. And you also do have a project folder where you can have the plots, the packages, as well as require some help if you may need. So in data cleaning, generally what we do is in our programming, we usually call the functions of the particular functions or objects that we know is in our environment on R. And then once we call the data set, the R will be able to give us something like this in a tabular forms. We'll be able to know how many variables we have in the data and how many columns that you have and what types of data. So why do we clean our data? We actually clean our data basically to ensure accuracy and uniformity of the data, as well as consistency within all the data ranges, as well as to validate to make sure that what you key in previously in your Excels or CSV files are actually what you see in the R. The same thing, the other good things to do is you need to have one pieces of information per columns, which normally people used to forget to do when they are populating a database for their data set. So no unclear values in cells, and then descriptive variables names with no space. All these are some of the things that make us to check the data and ensure there are no problems with the data, and to ensure there is no double entry. So this is typically the typical data cleaning stage that we do have in a general statistics, not to talk of R. You can have, you can read the files first, and then we can see it when we come to the practical aspect. We can read the files, the data files in R, and then we can either drop the columns or rename the columns or filter the data based on what we want. And we can also remove the duplicates and insert the variables that are missing variables. We can communicate with R and tell us which variables are missing. And then we can also export the data. We can clean it up and export it again in a writable way in CSV format. So there are associated packages that do all these kinds of cleaning stops. In R, we have what we call base R, and we have what we call the packages. The base R are actually the packages that actually came with R itself, while the packages, they are bundles of functions and bundles of codes that are there in CRAN, that is Comprehensive Archive Network, where people can download based on what you wanted to do with the packages. Just to give you a snapshot of what packages look like, is assuming you buy a new phone, you know, it usually comes with some default applications that may be used for you with you and other R packages. So while R packages is other applications that you may need. You wanted to, for example, you need Google Maps, or you need Grab car or Uber applications, so you can add it. So it's just R itself as your new phone, while R packages itself as applications for which you need to actually make use of R. So there are common data cleansing continuous, as we say. We do have a range of packages. These are dplyr that you can use to remove columns and other packages that are of importance when you are doing data analysis. So all of these packages that I mentioned above, they are actually comes in bundles and bundles of codes. And these bundles of codes is what we call tidybars. So in tidybars, you may have several number of packages. You can download the tidybars, and this tidybars is basically designed for doing data science. So you can see we have bundles of all these packages. They are collections of R packages within the tidybars. So we have a number of them, and when you install tidybars, it will install or it will come up with all of these packages that you are seeing, depending on which ones you wanted to use. So in R, generally, if you want to install a packages, what we do is not basically to say library tidybars in double quote. No, you can do that as well, but it will load small number of packages out of the previous packages that you see here. It will load very small number of packages if you say library and then double quote, you call the tidybars itself as a packet. What you usually do is that you need to call functions called install packages, then you put this in a code and call it. But if you put library, is also enough for you to proceed with your data analysis. So that is basically what's the introductory parts of the data cleansing before we go into the data explorations. And when we come to the practical aspect, you can see how we do that. So the data explorations itself is a way to explore your data, look at how it is, and whether you can have a range of values, you can summarize the data, or you can have your histograms or whatever kind of plots that you may want. So basically, this is just to give you to see if you wanted to like examine the data. Let's say the data set that we have is a cancer data set. So when you call the name cancer and type it into the R console, it will come up with the data in a tables. Tables is just like a data frame that encode all your data and variables in columns. And this is one example. So you can see from our console and how it gives the results outputs when you call the function summary and cancer number 4. That is if you wanted to look at the column number 4. When we come to the practical, you see. So while if you want to visualize the data itself, there are ways to visualize the data, whether based on base R or based on the packages that we mentioned. And one of these packages that is inside the tidybars is what we call the ggplots. So in ggplots, we have a kind of functions, we can say that you can call it. And when you call the ggplot is just like a plot functions in base R. ggplots here is a plot functions in tidybars when you are using tidybars. So I can say in ggplots2, because ggplots2 is the general package that can give you the outlook of these data visualizations. So what it needs is that when you key in the data, this data is or what we call arguments in R. Whenever you call a functions, you need to top up with or you call an argument, and that argument, maybe for examples, we call the data, and that data set, we can call it diamond for examples, and then you can add the geo functions. And those geo functions, it could be bar graph, box plot, depending on your choice or what the nature of your data. So you can make a choice and think about how you can structure the data and visualize it within using the ggplot functions. And you can see we have artistic map. This artistic map is to help you tells which sides of the graph you want X and which sides of the graph you want Y axis. So we'll come to it. And so to visualize the data in data visualizations that I mentioned, basically we use the ggplot, but I will show you how you can use the base R plot functions also to plot the graphs without having to do with ggplot. But ggplot gives you elegant graphics, very intuitive graphics for and ready for publications. So usually the graphics, the ggplots tool is very powerful and flexible packages for visualizing data in R. And it actually works in combinations with all of these packages. It actually comes from the tidyverse. You can see, if you remember the previous pictures I showed, it shows you all the basic packages that we have in all the major packages that we have in the tidyverse. So out of these packages, we have the ggplots. ggplots is the ones we use for data visualizations. So this is a typical template that usually data scientists need to master it or know it ahead. We use ggplot. As I said, ggplot is like a plot functions in base R. So ggplot here is a plot functions in ggplot2. So you need to key in the argument, which is the data, and then you call the geo functions. Geo functions could be, if you need a bar graph, you can say bar graph, or if you need a box plot, you can say box plot. If you need a line plot, you can call a line plot. So that actually depends on the nature of your data. So you can even map it. And when you are mapping the data, you can call the X and Y axis. That is where you want the X axis to be placed and where you want the Y axis to be placed. But this is basically the general template used in ggplot2 functions. So to further elaborate on this, you can see an examples like this. We have ggplot, and then we call the data set. This is belt data, and we key in the argument, and then plus. Remember, when you put the plus here, and you need to take another line. If you cannot take another line, you can give a space, because if you did not do that, R will give you an error code. So make sure the plus is here before taking a new line, and the new line will start with the geo point, and that geo point could be mapped into your artistic graphics, which is Y and X axis, as I mentioned before. You can define, you can see the budgets. We need the budgets to be in the X axis, while the Y, the dog gross to be in the Y axis variable. So this has defines the templates above, how you can structure your data as well. So we have geometries and artistic. If you go back to the previous slides, we have geo and artistic. These two points is what I will elaborate here. So geometrics are types of plots generally that we have. As I mentioned before, we have the geo points, the geo line, the geo box plots, that you can plot box plots, bar plots if you want with columns, and then histograms if you want to plot for histograms. While artistic are graphical parameters which can be adjusted in a given geometry. So the parameters could be X and Y. So the geo functions, you can find them in the mapping, where if you go to the website, ggplots2 functions, you can have several number of cheat sheets that you can check and find out more information about how geo functions works. So for the artistic mapping, as I mentioned, you can see we have the geo here without having to call the data, but you can just mention the data by the name, then plus geo point. You see the mapping. This is the artistic property. is also called an argument because we key in, we tell the R what we want, what types of color we want the X and Y axis to look like. So it will bring up the graph with the types of color that you selected. If you look at it again here, you can see you can change this artistic property to size based on color, based on map, based on locations, based on position. So depending on what types of artistic property you may choose in your graph, and that solely depends on the nature of your data. So the code for how the codes are structured in the graphs is actually depends on the nature of the data, whether the data is in the table forms, and you have the columns format, and then it will generate a kind of a graph that you have that you may want. And then say which, for examples, if you have a point, line, or bar plot that you may want to represent, or you can also add some results or some values or some data on top of the bar plots. And you can also customize, the GG plot based on colors, based on labeling, and a number of annotations. So for examples, you have these artistic geopoints. In the geopoint could have X and Y, alpha, color, fields by group, by shape, by size, by stroke. So that solely depends on the nature of the data that you are working on. We are going to see in the practical aspect. And the mapping can also be quantitative or in a categorical way. If you have quantitative data, how you can map it is different from how you can map the qualitative data or categorical data. So you can see the mapping plots, for examples. We give an examples like this. We say GG plot, we use expressions data, and then what we want to plot wild type and core. So we key in, then followed by the geopoint. So this is how usually you can structure your data when you are using the ggplot functions, and this is how the graphs will look like. And this is the second graph. If you want to use the line, if you look at the difference between this graph and the previous graph is just the change in jaw lines. We changed the jaw instead of using the jaw points, we use the jaw line. So the jaw lines brings up the data in form of a line graph. The same thing here, we use expressions data, we use piping. We pipe this data, meaning to continue with the ggplot, and then we add the jaw points to make the color. We can choose the color that we want based on jaw points. We say red2, and this is how red2 color looks like. And then we tell what kind of sizes we need each dot point to look. So to look CS in terms of whether it's small, whether it's large, whether it's medium. You can increase the number if you want. And there are a number of other types of geometries, which are called plot types that we mentioned also. GeoBar or GeoColumns that you can use, and then GeoHistograms, density, violin, and box plots, and a number of them so you can find in ggplot functions. You can also draw a bar plot using the columns or GeoBar. These two functions, you can use them to depend, and that solely depends on the nature of your data. You can use them to plot your graphs in both ways.
Zoom.
And likewise, you can use the GeoColumns. Here, you can key in these arguments, and you can change the nature of these arguments, or what is your Y, or what is your x-axis, where you want to place the genes, or where you want to place the samples. So a bar height, for examples, like this ggplot, we use expressions data, and artistic graphic, we key in the x-axis to be gene, while the y-axis to be wild type. So you can see the wild types, and the number of genes that we have, and the number of genes. So you can also use GeoBar to count the number. You can use mutant data, for example, and you can pipe it into X mutations. That is, you key in the artistic values without, for example, because the data doesn't have the y-axis or whatsoever, so we use the x-axis. Just we need the mutations plus GeoBar, and this is what we can see the kind of mutations graph that we have in form of count, because we didn't give values for the for the y-axis, so it does show us only the mutations that we key in. We define the x-axis as mutations, so it brings up the mutations in the graphs. So the same thing, you see, we change the means. We use summary, we use mutations. Now we key in the y-axis, mutant reads, and then we need it with a kind of like a summary and mean. So it gives us with those values. You can also do other types of plots like star groups plots using the zooms. You can use those values. And here you can use the geo column instead. You can see the only difference is that you put in the positions and the fields value. If you look at it, we added the fields using the genotype, so it categorized the data based on genotype and the wild type. So there are plotting distributors, histographs that you can see. You can also plot, for example, you can plot the histogram using GeoHisto. The only difference is that you have the histogram. Likewise, if you go into here, you use the violin. So the difference between them is just the violin, and the previous one is we use histograms and the other arguments that we can change, whether black, whether yellow, whatever types of color we need. Likewise, you can change it to box plot. You can see when we come to the practical aspect. So we use the box plot. You can put the color and the yellow part. So there are some annotations and scalings, as well as the coloring that you can do in ggplot functions. You can set out the main titles of the graph, the x and y axis. You can give them title, just like the way you can use in the plot functions in base R. So you can also use other set of functions that are there incorporated in the tidy bars in GG2 plot functions. You can also change the scales, and you can also add the scaling options that you want. You want to reverse it, you want to flip, like some graphs. If we come to the practical, you can see how we can use this coordinate flip and flip the graph the way we want it, whether horizontally, vertically, etc. So in annotations, also you can look at how you can structure based on X and Y. If you look at it, you can use the coordinate Cartesian graphs. You can give the arguments also, X limbs, Y limbs, then only it comes up the way you define it. Also, you can have other theme. Maybe you may want your graph to be dark, to be light, to be minimal. All these types of graph, you need to add a theme to the ggplot templates that you saw before. So you can also customize the theme. You can see the set of themes for the globally, and if it is a single, you can define with a plot title, and with the elements, you can also adjust the values the way you want it. So you can see these are quite a number of themes that you have in the ggplots too. You can refer to this website and find quite a number of the customized themes. So it depends on what you are looking for. So you can go and read more about them through this link. Likewise, the theme setups, for example, so we can set up the themes as in previous one. instead of using 0.5, we use 1. You can see how the sizes changes. You can see in the following ones, we use if you go back, you see this one becomes white, and you can also have a number of colors that you can choose depending on what you want. But generally in the scientific community, people use this, or scientists use this, the color braille for qualitative data, while color distiller for quantitative data. But it's your choice to choose how you want your graphs to look like. So these are basically some of the functions, sorry, some of the colors that you can find in the ggplot. But generally, scientists are still arguing whether to make your graphs like this or to make your graphs with coloring. But the general acceptable way, people now are going toward these types of graphs because people want to see the data themselves. They want to see what is in the data. For examples like this, they can see clearly the distributions of those data. But if you use just a bar graph, the bar will just close all of these distributions of the data. It cannot be seen. The same thing with this, you can see the distributions of the data. You can see what we added here is just the GeoGita, and you can change the color, the gray. If you look at it here, the color, we change it to, we added these values as the gray. So after plotting your graph with GG functions, you may want to save it. There are other a number of saving functions, functions for saving purposes. You can save the graphs based on whether you wanted to save it in PDF, as some journals are requiring you to basically plot your graph in the PDF or in PNG or TIFF. So it depends what types of format you want, but the basic functions is ggSave. You can use ggSave and call the name of your plot. You can name your plot and give it the outputs that you wanted the outputs to be, whether PDF, whether PNG. And you can also specify what size, because some journals, they will tell you, okay, we need these sizes, whether vertical or horizontal, we need this type. So you can change it in the ggplots2. It has these functions that you can use to plot the graphs, to save the graphs. So to make a graph in a general way, this is just the formula. You can pick up the data. You can use these templates. I have shown these templates before. You can use these templates, and remember that the first argument is your data plus the geom functions, and that is geometric functions. And the geometric functions could be bar charts, could be histograms, could be line plots, could be box plots. So you can choose based on your data, actually. So while here, for the mapping, you can use artistic map. You can map the properties for the variables X and Y. If it doesn't have, you can just put it as X. You can think about the feeling, the colors that you may want to choose. So ggplots2 templates usually have what we call cheat sheets, and this cheat sheet, you can find it in ggplot website. It's a data visualization packages that you can use. So there are quite a number of functions and objects that you can use inside ggplots2 to aim at high quality graphics for the required publications in the top journals. And you can also remember to look at this. You can see the ggplots. The first argument we mentioned is the data. And the second one is followed by the geo functions. And then what else? Mapping. You can map X and Y. You can state the positions and coordinate functions, passating, scaling, and the theme that you want. So this is the general idea and the general template for ggplots tool. And this is the website for the ggplots tool, and you can have the link above, and you can visit it and have a look at it. You can learn so many things. You can also download the cheat sheet to serve as a guidance, like a pocket guide. So there are other books that you can use to actually explore more about data visualizations, data cleansing, tidying, and mapping as well. These are the elements of data statistics you can find online. Most of these books are actually freely online because they are like open science. So they open it up in the GitHub repositories. You can find with some of their data that they use. You can also download the data set and try to like practice. But the popular book that everyone is referring to is this R for data science. You can visualize data, you can model data, transform data, and tidy it. So all of these books are actually free online, so you can download them. But if you prefer the hard copy are usually on sale in some of the website for businesses. So with this, I will say thank you. Unless you have questions that you want to ask before we move to the analysis itself. Thank you. There is no questions. Can we move on to the analysis part? Is there questions, please, audience? Hello, can you hear me?
I can hear you.
Yes, we can hear you.
Yeah, is there a question?
Yes,
I think for nobody. Okay.
Are we
Yes,
just
yes.
restricted to the ggplot for our own analysis, or we can use another package for that? Thank you.
Very good questions. There are a number of packages that you can use, but ggplots2 is the most elegant and most popular among scientists. That is why scientists usually refer to it for graphic visualizations and other analysis stuffs. But basically, if you can go to the CRAN, Comprehensive Archive, archive network, where you can have a deposit of number of packages that are actually solidly used for data visualizations and analysis. It's not only restricted to ggplots alone, but ggplot is more popular. Thank you.
Hello, thank you, Doctor.
You're welcome.
Sir, may I ask, sir, the use of ggplot for data visualization?
Yes. He is muted.
Hello, sorry, sir. Can you hear me, sir?
Yes, we can hear you.
Okay, my question is the use of ggplot for data visualization.
Yes.
Is it only data that has been analyzed on R that can be visualized through ggplot, or one can analyze the data on another package and come and use ggplot for the visualization?
I can say you can analyze the data on even another softwares like MATLAB, like JABS, like other statistical softwares, and even Python. But you can only impute the raw data to the R or to the ggplot to be able to visualize the data, but you cannot come up with the analysis that you have done in other analysis softwares and say you can import it into ggplots and think about visualizing it in a different way. But you just have to use the raw data. But you can use the raw data, for example, in SPSS, in MATLAB, in Stata, and you can still import those raw data from those softwares into R, and you can use ggplots to visualize the data. Hope that have answered your questions. Thank you.
Exactly. Thank you very much, sir.
You're welcome.
Please, if
Any
you
other
have
question?
questions,
Yeah.
just tell us your name that, because I won't unmute you, because once I see any noise, I may count it as noise. Just tell me your name and tell us your name, and then go ahead with your question.
If no questions, can we move on to the practicals aspect? Hello? So, Dr. Phillips, can we move on to the practical aspect? Dr. Sadiq.
Maybe before we proceed,
Dr. Sadiq.
can you set something, because these are objects in R, and I know the little knowledge.
Dr. Sadiq, can you hear me? Dr. Adamu Sadiq. Okay, I think he's talking. I think he has a question.
Okay.
He is the moderator. Let him. That's why I don't want to talk. I want him to moderate everything. Thank you.
No problem.
Hello.
Yeah, Dr. Philip, I don't
Yeah, I think it's like Dr.
think Umar got
is having an issue with the network. Let's give him the last chance. If not, then after that, Dr. Umar, you can continue.
Okay.
Thank you. Dr. Umar, please continue. Then let's wait. Hopefully, you will have his question by the end of the day.
Okay.
Thank you.
Okay. So basically, this is you can refer to this website if you want the slides for these presentations for this webinar. You can also have the slides are here. You can open up the slides and download the slides from there. You can also open up this data and download the data. Or if you are fans of using GitHub, you can basically go over to Discord and download the zip completely. It will download you all the folders. So this is about the today's webinars about the data cleansing and overview. Let me share the link so you can have access to the materials. Here is the materials. So once you are in this website, you can quickly read about the technical aspect of it. If you want to like install the RStudio, set up your account if you want to use the RStudio cloud, or you can have a look at R. If you don't have R installed, you can install the latest versions, which is this, and the RStudios, the R itself, the latest versions, and you can download the data set that we are going to be using for the practical aspect. It's within here, so you can also follow along. So that's all about the data set issue, and let me move on to my R. Okay, so once you download the data set from the sites that I sent you from the GitHub repository, the name of the folder is data visualization. So you can open up the data like this to see the data, and this is the project about the project, and this is the license terms, and this is data exploring and cleaning as well. And then this is the data visualizations script. So this is actually the RStudio, where you can make use of your R to analyze the data, and you can open up the scripts if you want to open new scripts. That is, if you want to write a code here, and you can use here to run a code directly without having to do with the editor. We are using the editor to basically save our code, maybe for future use or for others to repair, just like the way I show you in that website that you can download the R codes that we can be using, and maybe later on you can refer to it and make use of the codes. And this is where you can find the slides and the README file about the programs. So to start with, this is actually the script where we can import the data. Then, but when importing the data, before importing the data, we have to like install the packages. So that is why if you see here in R, anywhere you see a command, whether R or Python or any other programming languages or batch programming, wherever you see the hash tag like this is actually telling the programs that not to consider this is not a code, this is a comment. So we use this to like guide people using the comments, or also guide yourself as a scientist or researchers. Maybe later on you may want to share this code with your friends, or it will be much easier for them to refer. For example, you can say install packages. We want to install the tidyverse packages, or we can load it directly if we already, because I already installed it, so I don't need to reinstall it again. But if you wanted, if you don't have the tidyverse, which is the software, I mean the packages that we are going to be using, you can use this to install it. Install packages. You can use this to load the packages. When we say run, it is now, you see that all these packages has been loaded, and you can make use of it because I already installed my packages, so I don't need to reinstall it here. And if you want to know more about data importations, you can have a look at this website. You can have other documentations. You can see I can run this code. If you are using Mac, you can say Control Enter. You see it refers me to the website, the CRAN website, where it will show you the details on how you can import data sets in Excel or in CSV or in TXT format. You can either use, if you are using a Windows computer, you can use Control Enter, but in MacBook, those of you using Mac OS, you can use Command Enter. Command Enter, or you can run it from here. You can basically go there and run. So we have a CSV files that is located here in the data. You can see the CSV, the data set called cancer. So it's a data set for cancer studies. They collected about 350 something data of workers with cancer. They are actually workers with cancer. They are trying to study anxiety in workers with cancer using this data set that they collected. So for us to import these data sets, what we need to do is, because it's in form of CSV, you can see it's a CSV format files. What we need to do is that we need to load a library that is called readr. Readr is actually a package that is inside tidyverse packages. Because I already installed my tidyverse, all I need to do is to load it. I already loaded it, as you can see from here. So since I have loaded it, I just need to load this library to make it function. So I can load library readr, and I can give this command. I want to save this data as cancer, and I use this operator. This operator is pointing that this highlight is defining this. So what we need to do is to use these functions read CSV. For example, let me just manually say cancer, and you can use this operator like this and say read. You can see R will automatically pop up with what functions you are looking for. So if you are using delimited files, if you have TXT files, you use delimited, or if you are using the CSV as we have, we use the CSV functions. So this is how it works. Once it shows us this, what we need to do is it will open up your bracket. I mean, open up a bracket like this. Like this. I say read CSV, you see it will automatically open up a bracket. And I can now name the data. because the data is located in this folder, and this folder, we usually in programming, we call it a directory. So we can say data cancer, then we name the name of, we can give the name of the data set, which is cancer.csv. We can say cancer.csv. So we can run this. Once we run it, you can see that something has popped up here in your environment, where it shows you that it has 355 observations, and those observations are our samples, or the number of samples are 355, while the number of variables that we have, there are 61. So this is basically how you can import the data in R using the tidyvars functions that we show in the presentations. So to look at the first 6 data, you can make use of head. Once you call head, another automatic bracket will open, and then you call the name of the data set. Once you call the name, you can hit comma, enter if you are using Mac. You can see that it shows us the data, the informations about the data, but the informations, if you use head, it will give you only the first 6 variables, or the first 6 observations of your data. So you can have a look about the data and what types of data you have to look at. You can see from here, you have 6 by 61. You have 6 out of the 335 and 55 observations that you have. And another way to import your data sets differently is using these functions. You can say it's the same functions, but you need to key in another argument, call it file.choose. So when you call like this, let's say comma enter, you will see it will direct us to our computer to ask about the files. For example, like this, you can see when I hit comma enter, it will direct us to our computer. So if you have the data, all you need to do is to say here and hit. So you can see the data, it still appears like the previous. So you can see it now imported the data into here. So 2 different ways to import your data if it is in CSV format. And another way is you can even generate the data yourself by using cancer. For example, I want to generate a random samples of data. I can call data frame as my functions, and I can key in Q1, Q2, Q3, Q4 as my sample, and I can end it. And I can run. Once I run it, you can see it created another observations called cancers. The only difference is that this one is cancer, this one I added S to differentiate. If not, the R will overwrite the previous data sets that we imported. So that is why I differentiate between cancer and cancers. I added S so that it will not overwrite the previous cancer data set. So when you hit on this, it will show you all the informations about the data here. And also the same thing with this, you can see this data that we created is appear in our environment temporarily. You can also view the data. If you want to view what is these functions, you have, these are all from base R. You can say $view. You see it pop up with a health menu where you can read about what is the functions of these objects. I mean, of these functions. What is the main usability of these functions? So you can check and look at how it is, and sometimes you can refer to the basic examples that they usually give. But basically, this is what you can use. You say view, and then X stands for the data or the objects that you want to look at. For example, we have this our cancer, we say view cancer. So when we click run, you see it pop up and comes up with the data. So we can check around and see how many data we have and how many columns, how many whatever we have using a single view bracket cancer. So we call the data. The same thing if you want to view, you can say view, you can say view and call cancers. If you want to call like this, cancer. So you see the data set that we created just now is pop up here showing us the cancers. So that is basically how you can view the data. And for the descriptive part, if you want to summarize the data to look at mean standard deviation, you can use the functions called summary from base R and call the data and say summary base R. You can see it summarizes all the data in the console. You can see starting from the questions number 1, 2, until all the total number of observations that you have in the data set. The same thing here. Sometimes you may want to just look at one variable. Let's say I just want to look at variable number 4 from the data. So you can say summary, call cancer, and then you call 4. So when you run it, you see it only shows you the summary of education, which is a variable number 4 in the data set. The same thing if you want to look at a particular data, you have a summary in another way, you just want to name it, or based on its name, you want to summarize it based on its name. We have a column of a data set called how long, that is how long they have the cancer. We use summary cancer and you can hit enter. You can see it will tell us null because the class we did not define. So what you need to do is that, let's say we can call, let's say summary. Let's say the function summary. We can call cancer our data set. You can use the $sign. Once you put in the $signs, it will pop up with all the rest of the columns that you have in the data set. So if, for examples, I want to see about the how long and I hit enter, it will show me the summary statistics for mean, standard, median, and maximums and quartiles number for all the how longs. So if you want to list the variables in the data set, just you can say names, you can use the functions names and call the name cancer. You see, it shows us all the variables that are key in the CSV files or in our observations. It shows us all the data set. I mean, all the data, all the names of the data, all the names of the columns that we have. You can call the functions names and call the data set. What if you want to know the number of rows and columns, you can say n row or n columns. Just n row, n columns, and hit enter. You see we have 355 number of rows. You can also say, okay, for number of columns, you have 61 number of columns. So this is how you explore your data. And if you want to see what nature of the structure of your data set, you can look at it using SDR and say SDR. You can see that it tells you the number of observations, the variables, and it tells you this is a data frame. You can see this is a data frame. So it tells you this is the data frame for and they are all integer. You can see the observations are in all integer. So This is how you can explore your data. And you can look at height, which will show you the first 6. You can see the first 6 row. And if you want to specify the number, for example, you want to see only first 5 to explore, you can use first 5 and it shows you the first 5. Or if you want to see all the rows but the last row, you can use n-1 and it will show you like this, something like this. You make maximum. You can use the head to look at the first 6 row, and you can also select, if you want to select a particular rows, you can use dplyr. Dplyr is also another packages that are in tidyverse. We basically use it for data manipulations. Unfortunately, this workshop is just for exploring, but we just have to like make use of it to select for a particular rows of our interest. So for example, we can say n sample n cancer 7. So if you click on it, it will give you the first 7 numbers that you have, the number of samples, because we use the library dplyr when we load it. And if you want to select randomly, you want to select, for example, you want to select a random number, maybe you want to select first 10% or 20% or whatever percent, all you need to do is to use sample fractions. Remember that all these sample fractions and sample n that you see, they are actually functions inside dplyr. Dplyr is a package, so you cannot have all these functions without loading the dplyr. So dplyr can provide you with the sample X, and you cannot have dplyr if you did not install the tidyverse. So when we click on here, you can see we need to clear this because we reached something. Let me clear it. And let's say we run here, you can see it gives us the number of rows, and it gives us the fractions of the first 10, the 10% that we want. This is the 10%, 1 to 16. This is the 10% that is randomly selected from our data set. And sometimes you want to look at the number of fractions, the missing values. If you want to look at the missing values, all you need to do is you can say column sum, and you use si.n. You can call it like this, and it will gives you values with the columns that have all the missing values with 0, 0, whatever. And sometimes you can say, okay, you want to see only a single data set. For example, inside the cancer, we want to see how many missing value in gender. When you click run, gives you 0, the number of missing values that you can have. And here, if you want to clear the environment, maybe you don't want to see all these created data set, you can use rm list and list the directory, for example, ls, and say run. You can see this is our list of character. Or you can use Control L. If you use Control L to actually clear the console, if you want to clear the console, you either use here or you use the Control L, or you can use the cat 014 in code. So you see it has cleared the areas. So this is basically how you can use base R functions and tidyverse functions collectively to visualize, to explore your data, to see what you are missing, or what you have in the data set. So for the visualizations, we have another set of code that you can use for visualizations if you want to visualize. Because this webinar is basically for biomedical scientists and biologists, so we make use of some data set, because R usually comes with bundles of data inside it, so that you can use to practice your data science. When you click library data set, it will load the data sets in R. And sometimes you may want to know what are these data sets. You can use question mark and call data set and hit enter. So you can see it provides you with, this is base R data set, meaning that we have a number of data sets that are within the base R databases that people can use it within R and analyze their data. So now that we loaded the data set, in the data set we have quite a number of data. For example, we have iris data. You can see it automatically pop up with the iris data because we loaded the library of the data set. But we don't want to use the iris data. We want to use the DNS. The DNS are actually the data set used for the ELISA within R. So we want to demonstrate how you can plot the graph using it. We use head. If you remember just now in the explore, data explore, we want to explore using head and hit run. You can see we have the concentrations and the density of each of the run. And we can summarize it, can say summarize, and we can have the mean, minimum, median, mean, and whatever types of descriptive statistics you can have. And you can also plot it like this. You can use plot functions. This plot function is not actually coming from the tidyverse collections of packages. It's actually coming from base R. When you install R, R basically by default, it has this function. So you don't need to install a secondary packages for that purposes. So you can use plot and call it in bracket DNS and hit run. So you can see the graph of the concentrations. You can see where it plotted. Are you all seeing the plots? Hello? Hello?
Yes.
Yes, we can see.
Yeah.
Yeah, we
Great.
can see the plots.
Yeah, so you can see the plots of the optical density versus the concentrations when you use just the plot functions. And you can export it. For example, you can save it as image. You can save it as PDF. If you say you want to save it as PDF, you can name it and it will save it inside the directory. When we say directory, inside the folder here that you are using for R. You can say view before. If you uncheck it, the plots, if you uncheck the plots, it will not save the plot. I mean, it will save the plot without showing you the plots. But if you put view, it will preview it. You can preview it before it save it. And you can, you can change the size. You can change whether you want it in A4, US letter. And you can also change the width and the height of the plot. So for basic plotting, you can use plot. This is our data set, the DNS. The DNS is our data set, while the concentration is one of the column variable, if you can see. So we want to plot DNS, we want to plot this concentration versus the density. So we have to define, for the plot functions, we have to define which data set are we taking the concentration from, which is from the DNS. And for this one also, we have to define which variables we want to plot from the DNS. So we define as the density. So if you click run, you can see the plot it runs. It gives us the DNS concentrations the DNS density versus the DNS concentration. You can also customize it. When you are customizing this plot, remember all this plotting we are doing it within the base R functions. We are not doing it inside the tidyverse graphics. So the DNS, you can call, as we call it just now, the concentrations and the density. We have something like this. But what if we want to name the X lab, that is the X axis and the Y axis? We also want to like have a column. We want to make it red. When you run, you see it plotted a very nice graph ready for publications, even though we are not using the intuitive graphic for ggplots2 functions. You can also use the histogram and box plot. When we want to histogram, all you need to do is to call the hist, call the data set, and what are the variables you want to plot. When we hit enter, you can see how the plots looks like. We have the DNS and the density plots. Likewise, if you want to plot for box plots, when we click hit, you can see the box plot, how it will comes up. So this is actually the basic data visualizations using base R functions. While let's look at the visualization in ggplot. You can see the difference clearly that the ggplot gives you elegant graphs and give you a very nice graphs for publications, even far better than the base R. So that is why now for us to use the ggplots2, we have to install the tidyverse, because I already installed it and I loaded it. All you need to do, you can, if you like, you don't have to install the collections of packages for the tidyverse to plot your graph. You can only use the ggplot, but sometimes you can be encountering some errors if you actually install only the ggplot without the other packages from the tidyverse. Because if you look at my PowerPoint presentation, you can see like there are collections of, they are like friends that you cannot separate them from each other, but you can still make use of the ggplots2 to plot a very good graph without the rest of the tidyverse family. But it is advisable, if you want to plot any graph, just install the tidyverse family together to be error-free. I mean, because whenever you have error in R, sometimes even the experts, you need to go and be searching in Google and Stack Overflow and the R community to start asking questions. So you can use install packages. This is functions you can use to install any types of packages. So you can say install packages and install it. But because I already installed this ggplot in my R, I don't need to install it again. But if this is the first time you're doing it, you need to install it before you can do the graphing. So we can load the library using gg2 library ggplots2 for us to see it works. You have to load it. Whenever you want to use it, you have to load it. Whenever you open an R sessions and you want to run a graph or you want to plot a graph, you have to load the library again. So if you look at it here, we have the library. Now we want to use the ggplots2. I define this data as gg equals to ggplots. If you remember in my slide for presentation, I made mentions of the ggplots. This ggplot is the same, is serving the same functions as this plot. This plot is coming by default when you install an R, as I mentioned, while this ggplots2, while this ggplot is actually coming inside gg2. Unless you install ggplots2, you can be able to use the functions ggplots. Otherwise, it will show you an error. So remember, with our templates, if you remember our template in the slides, what we mentioned is that you call the ggplots, forget about this because I am defining the data because I wanted it to appear in the environment. So ggplot, you call the data set because I still want to use the DNS data set. That is the data set. If you want, you can say data equals to something like this, but I just prefer to use the data set like this. So when you use DNS, you can call the artistic graphics. You remember, you can map it where you want the x-axis to be. We need the concentrations, y-axis, the density, and you need to add the plus geopoint, if you remember. So when you hit run, we cannot see anything. Why? Because we save it. We save it. You can see GG plot. And why do you think when we put the geopoints, it did not show any graphs? Because we did not add any argument for graphs. So when you add like this, now that I put in here, G equals to this, now I want to save the graph. GG save to GG save, and then I name the graph DNS histogram demo.png because I want to see the graph in PNG. But if you want to see it in PDF, you can change to PDF and then plot what? Then I call the data set because I already named the data set here, which is here. So now if I hit comma enter, it saves my data already. Now you can see, I can see the PNG file here. But if I change it to, let's say, PDF and hit again, run, you see it shows me the PDF files, and you can open the PDF, and this is the graphs. You can see a very nice graph when you compare with the previous graph that we used the plot functions in base R to plot is entirely different. So that is basically how you can save your graph in ggplot when you are using ggplot function. And sometimes you may want to print the graph directly. You can use this dot. It will just put down the graph for you like this. So we can have dot. You can see it only shows you null device once, which informs you that it has added a graphs here. So this is how you can save the graphs. So let's see other data presentations. There are other data sets in the dataset functions or packages from R that you can use. We say data and mtcars. Mtcars is another data set. If you want information about it, you can use question mark and call mtcars and call mtcars. Sorry, I say metcar. So I need to do like this. Then you can see it pop-ups in the house where it tells you about the descriptions about is a motor train car road test that was being used since 1974. So if you want to know more about the data set, you can take about the data set by just asking the R in question mark. R, you can say question, you can put question marks and empty cars. So when we run empty car like this, we will have the data set here, empty car, and we want a data frame using empty card, but now we want to plot MPG, cylinder, and this. If you can see here, we have cylinder, MPG, that is miles, number of cycle, cylinder, and then weight, you can see weight. So when you run it, what can we see? When you run it, you cannot see anything because we did not, we only save it here, empty plots. So when you want to convert this to a factor first before we can make use it for graph. So D, that is data frame, DR, from where, because this data frame is here, we define it already. Sorry, this is the data frame. You can see this is the data frame. We already define it here, so it saves the data frame. So we can say from the data frame, we want cylinder as a factor. So when you rerun this code, it now created cylinder as a factor. So when you hit head data frame, you can see, you can look at PVMG and the mills and the cylinder as well as the weight for each car. You can run, you can plot the data if you want to. We want to see like basic plotting graph. You can see Q plots. We can use Q plots, PMG, data, empty cut, and point. When you call it, you can see the PMG by its width is plotted. And the same thing here, you can put the, if you remember Q plots and ggplot are serving the same functions. So you can use, all of them are functions inside the ggplot too. So you can put in here point and hit run, and you can see the QQ plots if you want to use a with a continuous variables. Oh, we have seen an unexpected error. Let me see what is happening. Okay, so when we run the first line here, we have this, okay, and this line. So you can see this is what I expect to have in the graphs, because we want to have a scatter plot with a smooth line. So all you need to do, you define the geom. If you remember in my slides, you can see the point. You can define, let the smooth line be on a point, and you can name what kind of lines. You can say the smooth line. And you can also use to change the color. If you want to change the color, you can change it. You can see the cylinder by different colors. So this is how you can visualize it using the ggplot as well. Let's look at other data set. We have this tooth grow data set, and I have just loaded it. And you want to see it. We have in the tooth grow, we have the doors, but we want to see the data as a factor. So inside the tooth grow, you can call the objects, I mean the variables doors. So we say doors. Now we created the tooth grow with 60 observations and 3 variables. So we have the heads. If you want to look at it, you can see that it shows us the variables and the doors with length, with the length. So if we want to plot, now I can name these, the whole of this data set. I can name ggplot. You remember the ggplot? I put in the data set and I use statistic functions, X and Y. I want the X and Y to be dose and length, but I define the data as my data. So if I click enter, now I can see it created a list of my data. And if I want to plot box plot, for example, all I need to do, I can call this my data because I already created the data set here. I can say my data and I will only add the Joe functions. And these Joe functions could be box plots, bioline, or whatever. So you can run again. So you see I use box plot and it's successfully plotted the box. And I can use the byline plotting. You can see it plotted. So you can use different types of Joe functions to plot your graph. You can also make use of this. Let's say we use the box plot function. We see the data, how it structures. So now we want to flip it. You remember I mentioned flipping. If you want to flip, you can change it. We want it to be, we say flip, you see we flip it, the graph, and we can also make it to be notch. All you need to do is just to say Joe box plus, then you need to provide an argument. If you see in here, we don't have an argument inside the box plot functions, but here we provide an argument. We say we want it to be notch. If you put false, it will not give you the notch. So, but we put true, it gives us the notch. The same thing here, we want to plot by the means point. You can see we use the functions called start summary by means and the Joe point. Shape, we want the shape 18, the size 4, and the color to be red. If you plot it, you can see how it plotted with the means. We can see the means value for each dose with color red. So you can use also the single color if you want. You want to have like my data. You remember I'm still using the same data, my data that I created here. My data, Joe plots, and you can use the color. We need blacks and fill still blue. So when you run, what can we have? You can see we have the color to be black while the fill to be still blue. You can also change the colors by those. If we want to, we can only say Joe box plus artistic. We can only name the argument to be color equals to DOS. You only name the objects or the variables that you want it to be, what types of, what forms of color. When you run it, you can see it brings up with different types of colors based on doses. Another way, I still use this data set, but I name it here data 2. I took all this here, my data plus Joe, color, DOS, theme. That is, if I want to manually customize my color, you can use these values to key in what types of color. And when you run, and I run it, you can see the different types of color that I can have for my graphs. So you can also use the palette color. Run. You remember we created a data 2, so we can now use fit in data 2 and color brewery, and when we run it, we can have different types of color based on darkness. And you can also change it to be a gray if you want. When you change it, it will come a gray color. And you can also fill it by fill if you want to demarcate or differentiate between the supply that you have. We can use fill. So when we say fill, you can see how it demarcates the samples into 2. The same thing, we can change the positions. You can say, okay, this, when you want to change the positions, you cannot key in the argument inside the brackets. You can only separate them by comma. When you separate them by comma, then when you separate them by comma, then you can add the positions by dot. And when we run, you can see with positions. And you can also fill in manually with the column as we did it before. You can see, and we give different colors of our choice. And you can plot byline graphs. You remember the Joe functions. All we need to do, we used our data, my data set, and we change to violence. When you run, you can have the data violence. And when you use flipping, you can use coordinates flip to flip. You can see we flip the graphs, and you can also use the steel blue to look at the graphs in a steel blue. So we can create another data frame. Let's say we want to create DF those. We create a data frame with their length. We can run here. We create the data set as DF now, and we can see the heads if we want to. We want to run all of this code to look at the head. So now we define the whole of this data frame into data frame 2. We can look at the heads if we want, and we can check ggplot2 data frame because we name it data frame, and we can write the argument to us, something like this. And we can use F and stack identity if we want just the basic graph. So you can see we have only the basic bar graph for the doses. The same thing applies. We can use steel blue. All you need to do is just changing the arguments, adding the variables. If we want to add the variables, the jump text, the level, and we want to use the theme, the minimal. There are different themes as we shown in the slides. You can see we have the minimal themes with the blue that we want, the steel blue. The same thing goes with this labeling inside. We can label with the jar, and we can also label with the text. We can use the white background with the column, and when we run it, it will show us white, but we are only whitening the values for each doses. So this is basically how you can explore the data visualizations in R. And if you want to clean the consoles, we say we want to use Control L to clean out the console. So with this, that has come to the end of today's webinar. I can say thank you. Now is questions and answer sessions if you have. Thank you.
Thank you so much, Dr. Umar. It was a really wonderful lecture. Can you hear me, sir?
Yes, I can hear you, John.
Hello?
Yeah.
Okay. Thank you so much. It was a wonderful lecture. When you did the first demonstration using the base R, and you presented the data sets with histograms, I want to know, is there a way you can add the error bars, because it's didn't show. I want to know how you can add the error bars. Then another question is like the Python and MATLAB. I know you can use them to save and share data on NWB. That's without borders. I know you can still use R to do that as well. Thank you.
Can you please repeat the questions, because all is cracking all the way.
My network is poor. Maybe let me just type it. Thank you. Let me type on the chat.
Hello, good evening.
Yeah, good evening.
I have a question. This is Khadija.
Yeah.
What's the difference between an equal sign and then I think there was an like a less
Operator.
than like okay, the operator and the dash if you're defining a set. What's the difference between the equal sign and that?
They are actually the same, but it is advisable to use the arrowhead than the equal sign when you are defining.
Okay.
That is, if you are defining, let's say we want to define an X, something like this. Yeah, something like this. If I want to define maybe these values, for example, so I am defining X, I'm
Yes.
defining X as this. So I can also do it this way as X equals to this. So they are all the same, but it is advisable to use the one with the arrowhead.
Okay. And then earlier on you had two DF, you defined two set as DF. So does it mean that the second one will override the first one?
Exactly, it will.
Okay. Thank you.
You're welcome.
Thank you for the presentation.
You're welcome.
Good evening, Dr. Umar, and thank you for your presentation.
You're welcome, sir.
My question is on the description of graphs from R to individuals who have little or no knowledge about the software. You know, it is easy to describe graphs from GraphPad, SPSS, or even Excel to people, and most people have understanding of the outlook of these graphs, either in a bar or in some other patterns. How do I, as a researcher, explain graphs from my analysis to viewers or audience that may be looking at my graph? Thank you.
So this has to do with statistics. Unfortunately, this is what we do is actually basic data visualizations, but we are not doing with interpretations. I wish we do that, but due to time constraints, we are unable to do this. But because in R, we have what we call, let me go there. In R, we have what we call R Markdown, where we can analyze the data. We can make a report with our code as well as the graphs as well. So R, they have, we can even use HTML, or we can even create a presentations in R to put down all the graphs that we plotted and explains them. So the explanations about the graph actually depends on the nature of your experiment and what you are trying to convey to the public or to the scientists around. So that actually depends on you and what you see. But generally, if you do literature mining, you look at other researchers in your field who are doing similar research like you can find out how they interpret their data, especially in graphical format, so that you can be able to learn from that. I'm not sure if I answer you well.
Yes, thank you.
You're welcome, sir. How comes I cannot see people?
If you value keeping this secret, a secret. You have no choice to do this.
Also, I have a question.
Yes.
If we're not out of here soon, a letter will be sent to the Federales.
The codes that you used to take us to, I actually joined it, so I'm
You might think you can clean up what we saw, but you don't have enough time.
Someone
You're
is
vulnerable.
speaking from the background. I cannot hear you.
You're done.
What do you want?
Yeah. Can you
like
talk?
someone is playing something. Yes.
Yeah, you can go ahead with your question.
The question is the script that has these codes, even though I came late, so I'm not sure whether by default.
Yes, you can get it from here. Are you seeing my screen?
Now you can see your screen.
Yeah, you can get it from GitHub repository here. This is the informations about the webinar. We created a small repository. You can have all the codes here, and you can also have the data set as well as the slides inside here. So I will send you the link. I think Dr. Sadiq have shared the link before, but let me reshare it again. Yeah, I sent the link again. Yeah, for Kamaluddin Sanusi, the same questions. Yes, the same questions.
Somos
Yeah,
familia, there's no need for these formalities. I see you've all arrived in style in your beautiful.
Any other questions?
Hello.
Yes.
Hello, can you hear me?
Yes, we can hear you.
Hello.
Yes, we can hear you.
Can you hear me? All right,
Yes,
all
we
right.
can
Thank
hear
you. Thanks for the presentation. Please, I want
You're
to
welcome,
ask,
sir.
how can you work directly from the Excel sheet?
How can you
work directly from the Excel sheet?
You cannot work directly from the Excel sheet in R, but because by the moment you import the data from Excel sheet or CSV files from your computer into R, the R changes the data into a data frame, a form of table with the data. So you cannot like have a versions of Excel sheet into the R console.
Okay, okay.
Yeah.
So we can, so the R can, it can convert back to.
Yes, a
Hello?
data frame. Yes, it will convert it to a data frame.
Okay. Okay, okay, okay. All right.
Yeah.
Please, I don't know if you have anybody with question.
I have one last question, sir.
Okay, introduce yourself and ask your question. Thank you.
Okay. I'm Ahmed Mustafa. I understand that today session we had a webinar on data cleaning, data exploration, data visualization. So is it possible also to maybe probably in the future have another extension of this, looking at data analysis, where you can use those inferential statistics like ANOVA or regression using R? I'm just pleading and have that opportunity. Thank you.
Yeah, I think that's a great question. That is the next seminar, the webinar we're supposed to have. Actually, we were planning for 2 webinars. This webinar supposed to have taken place about 2 weeks ago. Then we are expecting this one this week, but because we did not yet have someone that will handle it, and we don't want everything to be done as a stretch. Therefore, look up for that. That will be next month webinar, and then that will be the last part of that. Therefore, what I will expect everyone to do now is to go download your R, use your R Studio, go and practice all what you have learned so far for the first and second webinar. Then when you should have enough questions when you are doing data analysis. We may humbly invite Dr. Umar as well, probably to be part of the webinar that time, that exactly to be able to answer some of the questions you are able to, the problem you may encounter during your practice. And then if we get someone that will help us to handle that, then that will be very great. Then I will notify us, and the Sadiq, that is the media coordinator, will be able to send the flyer around. Yeah, that is the next phase. Thank you.
Thank you, sir.
Is Dr. Damo online? It's like there is something with his network today. Yeah, if there's no, therefore let me help him to round up. If there's no any other question, I will want to join the rest of the AYS mentor and mentee to greatly appreciate Dr. Umar Ahamed. We are greatly honored. And it's very, very enriching 2 hours. And I believe our mentee and mentors will go and put it in practice. Then if they have questions, hopefully in the next webinar, it will be attended to. We are very honored. And I believe people have learned a lot through these 2 hours. I'm being on and off because I'm using both my laptop and my phone. Therefore, I sit down with this and to watch and to listen to the webinar. Thank you very much. We are very, very honored. And I can say it is very educative.
Thank you, sir. Okay,
let me quickly scroll through the comments. It's like I'm seeing something. Doctor, enjoy your cook. Okay, someone is eyeing my cook. Sorry, it's finished already. Thank you, Dr. Dini. It has been expository. so far. Okay. I think Dr. Umar did a very wonderful work, and everybody, they are appreciating it. We will, this is, I think, let me stop recording while we have visited it, not to have enough, too much data to upload. Unfortunately, we are unable to, I was unable to connect via YouTube, Facebook today. Therefore, we have to, I will upload this to our Facebook platform, that if you miss it, you can go and watch it and listen.